Today our video is going to cover section 7.6, which is polynomials, and our objective today is simply just to classify polynomials and write them in standard form, and we can even eventually just evaluate these expressions as well, like we've done in the past. The first thing is we need to cover some vocabulary, and the first thing that we're going to talk about is what we call a monomial. So really what we're talking about is if we look at the roots of this word, mono means one, and nomial, kind of the nomial, means term. So what we have is we have our definition is a number, a variable, or a product of numbers and variables with a whole number exponent. But what I really want you to understand is this is one term. We've talked about terms before, but a monomial is basically something that has one term. So let's look at some of these examples. The number 5, just the letter x, the product of -7 times x times y, and then we have the product of 1/2 times x to the 4th. Those are all single terms, and so we call those monomials. And so then if we look at here, what's not a monomial is anything that has a negative exponent, or if we have more than one term. And then if we have any kind of exponents or variables in the denominator, those make it so that they are not monomials. The next thing that we can talk about is what we call the degree of a monomial. And basically what this is as you can see, this is the sum of the exponents of all the variables. So we need to supplement this all variables. So if we look at these first couple examples, and then the last part of this basically says a constant has a degree of 0. Remember, a constant is just a plain number. So if we look at these examples, the degree here, this is 0. Remember, this has the imaginary 1, so my degree is 1. Here I have two variables. Well, actually I have a number which one is 0, 1, and 1, so my degree here is 2. And then here I have a number which is 0 and then an exponent which is 4, so my degree here is 4. So basically all you need to know for degree is counting up the total sum of all the exponents, where any number has an exponent of 0, well, not necessarily an exponent of 0, but a degree of 0. Okay, so if we look at some examples here, we can see that we have 3 examples here, and we want to just basically know what is the degree of these monomials. These are all my monomials because there's just one term. So here we have 0, 4, and 3, so my degree here is 7. Here, 0, 1, and 1, and so my degree on this one is 2. And then this is 0, so my degree here is 0. So all these monomials, this one has a degree 7, this one has a degree 2, and this one has a degree of 0. Next we move on to what we call polynomials. Now remember what we have is we have the word poly, which means many, and again the nomial is basically another word for terms. So what we can think of is polynomial means many terms. And basically what it is it's a monomial, or the sum and differences of different monomials. So basically what we're going to end up doing is we're just going to have multiple terms. So as long as we have one or more terms, these are all considered polynomials. And so we talk about the degree of a polynomial, which is just a little bit different than the degree of a monomial. And what it is it's the term with the highest degree. So we look at all the terms that we have, so all the terms of the polynomial, and then what we do is we say that degree of the polynomial is whatever the one with the largest degree. So let's take a look at these. So the first one here is this one. This has a degree of 7 because this is 0 and this is 7. This is 0 and this is 3. So my degree here is 3. So the degree of my polynomial here is 7 because this one here, this has the highest degree, so that's the whole degree of my polynomial. And if we look at the next example, This is 0, 2, and 1, so this is a degree of 3. This is a 0 and a 4, so this is degree 4. This is a 0, so this is a degree 1. And so finally, my degree is whatever this term is, which happens to be a degree of 4. But look at these two polynomials here. So if we take a look at these two things, what we're noticing is you see that these have multiple terms. So this isn't just a single term, a monomial, but it's a bunch of them either being added together or subtracted. So either adding a couple different things together, or we're subtracting, or a combination of the two. As you see on the second example here, what we're doing here is we're adding and we're subtracting. And so as long as we have multiple terms, we call that a polynomial. The next thing that we run into is what we have to do is we have to organize all these polynomials. And the way that we organize these polynomials are what we call standard form. And the standard form of polynomials is when we write them in order of degree from least to greatest. So what we basically need to find out first is we need to find out all the degrees of each term and order them from least to greatest. Now, this is where what we talked about when we added the opposite, that this is going to come into play. So before I do anything first, we're going to look at this polynomial here, the first example, and before I do anything, I want to add the opposite, just because what that's going to do is if I have to move things around, then I won't have to worry about what is negative, what is positive. So if I add the opposite here, I have a plus negative 7x to the fifth. Now I can move on to deciding, okay, what is the degree of each of these terms? Well, this one here, this has an exponent of 1, so I have a degree of 1. This one here, this is a 0 and a 5, because remember, constants have just a 0. And so this is degree 5. This one here, this is degree 2, and this is degree 0. So now what I need to do is I need to use my commutative property of addition to be able to move these things around and reorder this. So the highest degree that I have ends up being this term here, which is negative 7x to the fifth. The next thing that I have is I have degree 2, so I have plus 4x squared. Next to degree 1, I have plus 6x, and then finally plus 9. Now notice with this one, rather than some of the examples that we just looked at, is that we have one single type of variable. And this is going to be very common as we move forward with our polynomials, as most of the time we're going to see them with only one variable. We're not going to worry about multiple variable polynomials just yet, but we're going to talk about them and how we can simplify these and everything like that. Now with addition, the properties of exponents that we have don't apply. Remember, the properties of our exponents only apply when we're multiplying, we're dividing, or we're raising something to a power or something like that. Keep in mind, we cannot use these because of the addition. If it was x to the fifth times x to the second, then we can use our properties, but with something like this, we're just kind of going to ignore our properties for this moment and just order these polynomials. So let's go on to our next example here. So we have to find out the degree. This is a degree 2, this is a degree 6, and then I forgot to add the opposite here. And so then our degree here is 1, because remember we have that imaginary 1 up there. And so if I order this from least to greatest, I have y to the 6th plus y to the 2nd plus negative 3y. The other thing that we talk about when we talk about polynomials is we have this thing that we call a leading coefficient. Now remember, a coefficient is the number that comes in front of a variable, but when we're talking about a leading coefficient, it's the coefficient of the first term. Now we find this after we put it into standard form. So if we look at this example over here, the leading coefficient on this one is -7, and the leading coefficient here is, well, remember there's that imaginary 1, so my leading coefficient on this example is 1. And finally, what we can do is we can name these polynomials. Instead of just saying everything is a polynomial, with most of everything we have some kind of representation or a characteristic or a name that we call each one of these. So if we look at this table for a second, as if you notice, what we have is we have different degrees and we have different number of terms. So if you look down the list of the degrees, if we have a degree of 0, it's always a constant. If we have a degree of 1, we're talking about a linear polynomial. If we're talking about a degree of 2, we have a quadratic. Now think about this. This would be just the number, so 5, because remember numbers just have a degree of 0. This would be an example of x. So remember, everything that we dealt with in the stuff that we did before, everything we called linear because it had just an x, not raised to any powers. Something like this, for a quadratic, we would say x to the second power, or x squared. That has a degree of 2. X to the third power is what we call a cubic polynomial. And then we can keep going, x to the fourth, x to the fifth, and then on and on and on. Once we get to 6, you'll notice that we don't have a specific word for it. We just call it a 6th degree, 7th degree, 8th degree, and so and so. And then what we also have is we would name these, in addition to the degree name, we would have the number of terms. So the terms, so monomial, which we talked about, remember the mon, or the mono, means 1. If there's 2 terms, we call it a binomial. Bi means 2. Think about a bicycle, 2 wheels, 2 cycles. 3, trinomial, which triangle, 3 sides. And then again, once we get up to 4, we don't worry about a specific name, we just call these all polynomials. So let's look at the examples that I put down here. So first of all, we need to figure out what the degree of this polynomial is. Remember, the degree is always the first term's degree, or the highest degree. So this is a degree 3. So we call this a cubic function. So this is cubic. And then it has 1, 2 terms, and so we call this a cubic binomial. Okay, let's look at the second one. Since these are in standard form, since we know what standard form is, it's when it's ordered from least to greatest, we can look at this and we can say, okay, here's my degree. So this has a degree 6. Now this goes into the category of what we just call a 6th degree. 6th degree, and then we have to count up our terms. So 1 term, 2, 3, 4 falls into that category again. So this is just a 6th degree polynomial. Not a special name for it, but we're just classifying it as what it is. And then something like this should look pretty familiar to you because we've worked with stuff like this all year. And so we have 2x minus 3. This has a degree of just 1. So this is what we call a linear. And since it has 2 terms, 1, 2, we call this a linear binomial. So you should be able to classify these. So make sure that you're writing these down and you're remembering what we call these. The terms should be pretty easy. Everything is a nomial, whether it's a monomial, binomial, trinomial, or polynomial. And then the ones that I want you to become very familiar with over here, for as far as the degree of something, I want you to remember what it is to be a constant, what it is to be linear, quadratic, and cubic. I want you to really remember those because those are the ones that you're going to use the most often. So if you see something that has a power, not a power, but a degree of 3, you should tell me that that's cubic. Or if it's a degree of 2, that it's a quadratic. And then if it's a degree 1, then it's linear, and so on and so on. Okay, so that's about going to wrap things up for us today. If you want some extra practice, I would suggest that you go to section 7.6 in your book and do some guided practice. Now this isn't anything that I'm going to collect or anything like that. This is just something that you can try just to make sure that you're on board with everything that I've been saying. And so what you can do is you can try those out, reference this again, and see how things are working for you, and then we'll be able to talk a little bit more about this when we get into class.